Okay, so um, we were talking about kind of the mapping. Oh well, first of all, so how did the Mendix thing go? Struggle to get there. Now, how many of you who struggled did not use the version they told you to use of the modeler? I think it's what 7.8.0. The latest is what 7.11.
Yep.
Yeah.
So how many of you downloaded 7.11 and did it with that and ran into issues?
Oh, no.
I didn't run that.
So maybe you didn't through module 1 and 2, but you will later on because some buttons are in different places and stuff like that, or some things are hidden. You will have the best success if because when you go to the download page, they show you the last 20 releases of it. There was a whole bunch of download buttons, right? Download version 7.8 of the modeler. It's almost the same as 7.11. All the buttons will map up to the videos. You'll have less trouble. I'm going to install 7.8 on 3 or 4 of the Macs down there on the Windows side. And I'll probably just put 4 machines in a row, and I'll post on Slack which computer numbers they are. So if you sign into Windows on one of those 4 machines, you'll have access to that version of the modeler on there. I'll do that after class today. All right. Does that cover? Is there more than 4 people in here who don't have access to Windows at home? We have 1 person. Who else doesn't have access to Windows at home? 2. Anybody else? Okay, so I only need to get it on 2. I'll put it on probably 3. All right, I'll put it on 4. We'll put it on 4. I'll just do 4 in a row, probably next to the instructor station. Those 4, but I'll give you the computer number and what they are.
Do you think we should change it if we have 711 downloaded?
I would. I think if you want to minimize your headaches, because you have the next modules due on Monday and so on. If you want to minimize your headaches, download 7.8. It's almost the same thing. I know it's always difficult to not download the latest version. I always want to download the latest version of stuff. But life will be easier if you just use the exact same version that the videos are referencing. Yeah.
If we download 7.8, would the modules that we did already be there?
Yeah, it's not going to make any difference. Yeah. When you log in, you'll still see your project. Yeah, from your perspective, nothing will change except the buttons will be in the same place when later videos reference them.
So everything is saved?
Saved in the cloud.
Okay.
Yeah. It won't break anything.
Okay. Cool. So we do have to uninstall and delete that.
You may not even have to uninstall. I'm not positive of that.
Okay.
I would probably uninstall, then reinstall 7.8. Just have a fresh whatever. Then when you log in, it'll show you your project, and it might take a little bit longer to open the very first time because it'll download it to the machine under the new directory, but you won't have to redo modules 1 and 2 or anything. You might just have to wait 20 seconds the first time you open it for it to sync. All right, makes sense? And I put that up on Slack. I put that message up this morning, but 7.8.0, your life will be easier. Make sense? All right, I'll get it on 4 machines in the lab. But we probably haven't had too many issues up to this point because Module 1 and Module 2, they don't go very far in, right? So things are going to get worse if you don't roll back to an older version moving forward. I promise. It'll get worse. And that doesn't help what I'm trying to accomplish with this. So I'm actually having you go ahead with software development stuff. We're handling some of the theory-based information so that when you're kind of done with that and I'm kind of done with that, we can sweep into Python. Kind of see where we're going there? So you're getting some of the thought process practice, like, hey, I need to start thinking like a programmer with the Mendix stuff, but not having to worry too much about syntax. It's just more drag and drop and learning that tool. And oh, by the way, by accident, you're going to get a rapid application developer certification from that. And you can slap on your resume, and people might care, they might not. They probably haven't even heard of it, but it'll look good. All right? And then we could start diving into Python stuff. So everybody wins. Yeah.
Was Mendix made in Visual Studio?
To be honest, I am not sure what they're...
It looked very simple.
But the thing is that you would, at the exact same time, you would say it looks a lot like Android Studio, and it also looks a lot like Xcode, because we're going to talk about it, if not today, probably next time. They all have an implementation for something called MVC, which is the design pattern. So basically all those things that give you graphical user interfaces, they all look the same at the end of the day. To me, actually, it really feels like it's modeled a lot I bet you it's implemented in Java. Actually, that actually would not make a lot of sense. Because if it was implemented in Java, then it would be supported on the Mac. So it probably is not implemented in Java. But it really, the interface builder thing really feels like it's the same type of thing as Swing graphic user interface building in Java, or the way Android interfaces work. But that just means they're similar. Yeah.
I remember reading something about Java when I was going through some of the stuff.
Yeah. It just, I mean, their modeler at the very least, their modeler couldn't be written in Java. Otherwise, they're just jerks. Because if their modeler's written in Java, Java's a platform-independent language. We'll talk about that. But that means there's no reason why the Mac people couldn't download it and run it on their Mac. Because Java should run on both. Yeah, so the fact that it's Windows only kind of indicates it's, at the very least, that tool was not written in Java. Or again, they're jerks. Okay, so we were kind of talking about the mapping here, talking about variables, and then we're trying to understand how memory is actually represented under the hood. Quick question: how many of you have had Dr. Locklear in class? All right, so something he talks about, I'm sure he mentioned it somewhere in your class, is this idea of the grand ideas of computer science. Did he mention that in class? All right, so what does that mean? When he says grand ideas of computer science, what is he talking about? Go ahead.
Main topics, the main topics that shown.
All right, so, but what's really interesting about it is as you go through our program here, you're going to learn the same topics in multiple classes, but you're going to learn about them through different lenses. Because what ends up happening is when you look at computer science as a whole, you have all these kind of different fields that feel at the surface dissimilar. Artificial intelligence and programming and database and networking, a bunch of different stuff, but they actually all cross over quite a bit and have the exact same topics associated with them because at the center, they're all working with computers. So for instance, the stuff we're talking about right now, I talk about in a computer organization class. I talk about in a systems programming class. We just talk about them. We kind of have maybe 30% of the same material that we review, and then we look at it from a different lens coming in. Does that kind of make sense? So you're going to see this number stuff that we're talking about right now several times as you go through the program. You'll just see it from some different angles. So something to keep in mind as you go through the program, that there's going to be things that you're introduced to that you think you already know, but you're going to learn some new edge associated with it that's related to the topic that you're currently working with. Okay, so last time we talked about the primitive types that kind of came from our C programming language. So primitive types are built into the language. They can only hold a value. And we mentioned that 4 of these, byte, short, int, long, are all built for holding signed whole numbers. So are all built for holding positive and negative whole numbers. Now remind me, why do we need to have 4 different mechanisms for holding the same kind of values? What's the rationale for that? Go ahead.
They have different amount of space, so that gives us more options.
Okay, well, why do we care?
We want to be efficient with our use of space.
Do we? See, did I actually talk about this yet? Did we talk about the actual rationale behind it, or is that kind of where we were heading towards? Okay, so you tell me that we want to be efficient with space, right?
Well, you had mentioned last class we were talking about how there's lots of limited space early on.
Okay, yeah, so that was the transition.
That's kind of
So,
where I pulled it from.
yeah, so back in the late 70s, or late 60s rather, memory was really expensive. Really expensive. In fact, I did some math yesterday. It's pretty interesting. Let's actually look at this now. So today, let's just call it memory cost. So your average computer today, you buy kind of a low-cost laptop, it's probably got 4 gigabytes of RAM in it. A nicer one, 8 gigabytes of RAM. You might, if you splurge, you get 16 gigabytes of RAM. But 4 gigabytes is kind of our low end now for a starting laptop. Now, if you wanted to upgrade your computer with 4 gigabytes of RAM, you go into Best Buy. How much is a 4 gigabyte stick?
30
$30 bucks? Okay, so 4 gigabytes RAM is $30. All right, now we talked about the conversion between all sorts of bases last time, right? So just because we want to get cost per megabyte to keep things simple here. So how many megabytes is 4 gigabytes? 4 times what? 4 times 1024. So this is actually 4096 megabytes. So the cost per megabyte there is 30 divided by 4096, less than a penny, right? 0.7 cents per megabyte. So this is 0.7 cents per megabyte. Cheap? We call that cheap. All right, so now let's go back in time a little bit. Did I say last time I was inventing time travel? Is that in this class? Oh, well, we're doing it right now. You're seeing the result of my... So this is in 2000 or 2018, right? Now let's go back to 1996. How many were any of you things in 1996? Nobody was a thing. I was already hunting in 1996. Salt rounds and everything. So. All right, so nobody was a thing. When were we born? 99. Hey. Hey. All right, so what sucks is when I first started teaching, I was the same age as a lot of my students.
Really?
I was 21 when I first started teaching. Not so much anymore. All right, so 1996, I had a computer. We had to wait for the processor to get released. It was a 486 DX2 66 megahertz processor. Today you have 2.4, 2.8 gigahertz processors, and that's assuming they're even the same architecture. But just if you go off the speed, okay, this was basically a skateboard compared to a Ferrari. Okay, and this machine shipped with 8 megabytes of RAM. So 8 megabytes of RAM. Now, I decided to upgrade that machine to 16 megabytes of RAM. Now, just keep, so 4096 is what we're saying is our budget pleaser laptop today, right? 8 megabytes was state-of-the-art, bleeding edge, had to wait for them to release chips. So our cheap laptops today have 512 times more memory in it than I had in a machine in 1996 that was cutting edge, right? So I went out and got an 8 megabyte chip. How much do you think that chip cost me in 1996? Go ahead. $1,000. $1,000. Cost me $1,000. Now, you have to take inflation into consideration here. That actually comes out to right around $1,600 in today's dollars. $1,000 bought you more in 1996 than it buys you today. Make sense? That's how inflation works. All right, so if we use today's dollars, that chip was $1,600. So that means 1,600 divided by 8 is $200. Per megabyte. Okay, so how many 0.7 cents is in $1? So 100 divided by 0.7, there's that many of them. Times 200. Memory is 28,571 times more expensive today. Or was more expensive then. It's less expensive today. And guess what? You went to the sad part here?
What?
This was after memory had already come down in price. So let's go back to, I think it was 1970. There was a 1 megabyte RAM chip. I mean, and this is something they were not selling to consumers. It just existed. Okay? it just existed. And let me come up with the right. I think after you converted it to today's dollars, this was something in the ballpark of about 4 million.
What?
Okay. Okay. So that means we were 4 million
Yeah,
per megabyte.
that did come down quite a bit.
It's like, you think? It's like,
Really
it's
came
like
down.
reverse Bitcoin here. Is it safe to say, so we had a language, we've introduced C and said that came out kind of right around 1970, late 60s, something in that ballpark. If you're creating a programming language back then, do you think you want to be careful with memory? Yeah, you don't have a whole lot of it anyways. And what you have, really expensive.
Mhm.
Today, we don't look at it that way, right? Today, memory's cheap. We just don't care. You know, who cares, right? So, I mean, if we go back to today's programming, you'll never see somebody use a short today. I mean, back then you would have said, okay, well, if I'm only holding a value, I mean, so we come in here. When I say a byte, this is an 8-bit value, but it's a signed number. So that means we're using 7 of those bits to hold our number. What's the range of values we can hold in a byte? So the smallest value, well, let's go with the largest value. What's the largest value we can hold in a byte? That's going to be 7 ones, 1, 1, 1, 1, 1, 1, 1. What decimal number is that? This is 127. And the smallest value is negative 128. So back then, if you only needed to hold a value that was in the range of negative 128 to positive 127, you used a byte. Because that was going to be your smallest container that can hold all the stuff you needed to hold. Make sense? Mm-hmm. 16, so this is, if you want to write this more generically, this is plus or minus 2 to the 7th power. All right. This guy is plus or minus, because it's 16 bits, 2 to the 15th power, because one of those bits is being used for sign. So for a short, this is negative 32,768 to positive 32,767. That's the range of values that go in there. An int is plus or minus 2 to the 31st power. So this is plus or minus 2.1 billion. Long is plus or minus 2 to the 63rd power, which is plus or minus giant number. I think it's about 4 quintillion, something like that. It's the actual number, plus or minus 4 quintillion-ish. Now, you don't have to memorize any of these numbers. What we should appreciate is that, well, I mean, first, it's just math, right? If you had a calculator sitting in front of you, you could say 2 to the 7th, 2 to the 15th, blah, blah, blah. But regardless of that, we want to have an appreciation for this holds smaller numbers in a smaller box. This holds a little bit bigger numbers in a little bit bigger box. This holds even bigger numbers in a little bit bigger box. And this holds even bigger numbers in an even bigger box. And then if we need to hold numbers bigger than 4 quintillion, actually, you know what? I think it's 16 quintillion. 2 to the 63rd. Oh, it's 9 quintillion. Okay. All right, so, but whatever. If you need to hold numbers bigger than that, then you move over to object types in our languages that will allow you to hold arbitrary size values, and they just slow down the bigger the value gets. Doesn't matter. Okay? Reality for us is, if we're back in 1968, we really care about this stuff. Okay? Along 64 bits. 64 bits is 8 bytes. Right? So that's 8 bytes. Now, how many bytes are in a megabyte? So 1 megabyte times 1024 gets us kilobytes times 1024 gets us bytes. That's the number of bytes. So that is 1,048,576 bytes in 1 megabyte. So we need to take $4 million and divide it by that, and that gets us the price per byte, right? So let's just steal this number here. Oh, big money. So 4 million, 400,000, that's 4 million, right? All right, we'll divide it by that. So that is $3.81 per byte times 8. So to store a long in 1968 cost you $30. You were using $30 worth of resources to store a single 64-bit value. Right? Now, you got that resource back after you were done storing that value. That's expensive. We don't have a whole lot of memory available to us. Today, it's almost going to be unmeasurable, right? Today, you got your we've decided what was less than a penny, 0.007. 0.007 is how much we pay per megabyte. So now we divide that by 1,024. That's how much we pay per kilobyte. Divide that by 1,024. That's how much we pay per byte times 8. 0.000000534 cents to store that long.
Basically nothing.
We don't care. It's a rounding error. Right? It's free. So it's free. If you walk into McDonald's and that's what your bill came up for, they would just hand you the cup and say, go. Right? That's the ultimate get rich scheme, right? Go into McDonald's, ask for a cup of water, don't fill it with water. Start collecting cups. And then you just got to stay alive until like society breaks down. People are going to want cups. This is your bartering system.
Cup investing.
You're investing in cups. You go to somebody's house.
Is that our next homework assignment?
Just thousands and thousands of cups. Yeah, that would be an interesting an interesting assignment. Like who can bring in the most McDonald's cups? And then you do the cost per, you go in and you buy a soda, you're just killing yourself. You're paying 99 cents for a cup. You're not paying 99 cents for a cup. So if somebody comes back and says, yeah, I got 15 cups, but I had to pay $1 total. Like, no, get out of here.
Would they just give you a cup? Oh.
Go up and ask for water.
Yeah.
But without water?
You ask for
Dump the
they
water
give you
out.
a cup and-
Even if they fill it with water, dump it or drink. I mean, drink the water. You want to be healthy, just drink the water. Are you that averse to water? Here's a funny backstory here. So you might be able to tell by the nose, but I was born Jewish. My whole family is like Orthodox Jew. My brother and I are both Christians. I'm Lutheran. He's like a non-denominational type thing. But all these stereotypes about like money and things. My dad's one of 7 brothers. All of them are doctors and lawyers. Okay, my brother and I have always been entrepreneurial. We've started companies and sold companies and things like this. And so I remember when we were in high school talking about collecting stuff. In our biology class, we had to, we had this sheet where you had to collect a whole bunch of things that they would not do in school today. Like some of these things were dangerous to collect. Like we had to bring in a snake. They just go out into the wild and find a snake and bring it to school.
That's awesome.
That's not a thing anymore, right? You don't do that now.
No.
Okay, well, one of the things on this list was leeches. Okay. My brother decided these might be hard to find. So he found a source. So he's in school selling leeches. Dude made like $500 selling leeches to classmates. Got suspended for a week.
That's brilliant.
Worth it, $500. You're basically rich when you're that young. Yeah, $500.
Well, I mean, this is
Yeah.
in like 1920s money.
Yeah, so
So, I mean, that's basically $1 million. That's probably $800 today or something like that. That was like probably $800.
Selling leeches.
Yeah, it's like a drug dealer. You're selling leeches in high school. Nobody was selling drugs back then. We were selling animals. Maybe you had a school. You got the stuff. Little Ziploc baggie with water. Some of those things are really hard to catch too, like the crawfish, the crayfish. How do you catch those? They move Yeah, I get it. So now what you have is you have these high school kids like wading around in like local streams, trying to catch animals. You get like arrested today, like driven back to your parents, and like we found him in the lake. This was an assignment for a class. You remember that next time you complain about an assignment. We're not sending you out to the wildlife. It's like, okay, we're going to need you to bring back a sturgeon. Yeah, but this is due on Monday. I know Lake Michigan seems cold. So you're going to want a bundle. By the way, extra credit if somebody brings back a sturgeon on Monday.
Really? I'm actually going sturgeon spearing on the weekend.
Are you really?
Yeah, I'm not even kidding.
That's awesome.
Now, a true problem solver, if you were really trying to get a sturgeon safely, would be to go to Cabela's. Because they got that fish tank there, right? Let's go fishing in their fish tank. Get it? Hey, sir, what are you doing? I'll bring it back, dude. What's this?
Testing the fishing poles.
So you're going sturgeon spearing?
Yeah.
See, that's open, right? So.
I thought sturgeons were kind of like endangered.
No.
So, oh yeah, we're not supposed to be spearing them.
annual sturgeon harvest.
Oh my gosh, people!
Extra credit,
That would be a great picture if you bring one on Monday.
There's a limit of 7 sturgeon.
See, I fish, but I do have a boat. I go out and bass fish and stuff. I catch and release. My wife won't let me eat any of the stuff I catch. I don't want to have to like kill it and stuff. Anyways, I listen to my audiobooks and I fish. If I catch something, great. Not, you just pitch it back and you go over to. If you want fish, you go to the store. This afternoon, I'm going to a fish fry. You go to some place, you hand them some money, and they fry a bunch of fish for you. It comes out cheaper as much as I can eat. Take me a month to catch my fish fry fish. All right. Anyways, we went from we went from computer science to spearing sturgeon. Now back. All right. So in any case, we used to care. Memory was a major issue a long time ago. Now, does that mean it's never an issue today? No. Do you think over the years the problems we've tried to solve keep getting more and more complex? Where we're working with larger pieces of data. I mean, this guy's got a 30 gigabyte internet connection. So back in the day when you had dial up, you were getting 56 kilobytes. Actually, it was 56 kilobits. 56 kilobits. And you needed to download an MP3. How big's an MP3? 3 megabytes, something like that. 4 megabytes. All right. So 56 kilobits. Let's just divide that by 8. That is 7 kilobytes. Okay, 7 kilobytes per second. So 4 megabytes is 4,096 kilobytes divided by 7, 585 seconds divided by 6. That's almost 10 minutes to download one song back then. That was fast internet.
Wow.
But the thing is, this is before MP3s. We weren't downloading MP3s back then. So the size of the files we were downloading, well, actually, if you downloaded music sounds back then, you were downloading waves. WAV files, which are uncompressed. So 4 megabyte file might just be like one of those little bell sounds or something like that. It was because they weren't, MP3s are compressed. So if you had your high quality audio today uncompressed, that might be a 300 megabyte file. They're pretty highly compressed MP3s. But in any case, time, right? So if you're going to download an MP3 off a website now, you click the button. What's your expectation for how long it's going to take you to download that? A couple of seconds, right? Not real long. Slow internet, maybe it's going to be a minute max, and then you're complaining, right?
Yeah.
So you don't think anything of it. You see, oh, MP3, let's hear that song. You just click it. Where back then, if we had that equivalent of a 4 megabyte file, I mean, do I want to spend 10 minutes waiting on this? At best, that's ideal circumstances. Reality is probably more like 20 or 30 or 40 minutes, because now you're at the mercy of who's serving it to you. Just because you can grab it at 7K a second doesn't mean they can give it to you at 7K a second. And they might be uploading that thing at 1K a second. Now it's going to take 7 times longer. Kind of get the deal here. So things have changed, but also the types of files we download today are different. Like, how many of you have ever installed Linux on a machine just to test it out, check it out, blah, blah, blah? So, what's this?
Debating.
You're debating. So if you go and you download Ubuntu Linux or something like that, you're going to download 1 or 2 gigabyte ISO file, right? So let's say it's a 1 gigabyte file. Well, first of all, back in this time, that would more than fill your hard drive. You couldn't hold the file on your computer. Forget about downloading it over the network, over the internet. You couldn't store it. You didn't have the storage capacity to store a 1 gigabyte file. Today you're carrying around, if you're a cheapskate, you're carrying around an 8 gigabyte jump drive in your pocket or something like that, right? Those are the cheap ones. I mean, I got a whole. If you don't have a jump drive and you want an 8 gigabyte jump drive, I have a bag of about 300 in my office. I'll sell it. I'll trade it to you for a leech. Now, if you need one, I'll give you one for free. They're not high-speed ones, but if you do need an 8 gigabyte jump drive, I literally do have a bag of hundreds of them in my office. Okay, but in any case, times have changed, right? The types of the things we use our computers to solve is different than we used back then, so things kind of scale. Realistically speaking, memory is way ahead of the curve right now, right? We've seen in our example here, memory used to be considered expensive. Now memory is dirt cheap. We don't even think about it, right? There's a student in one of the other classes who has 128 gigs of RAM in his computer, just cause. Yeah, I mean, who's gonna use 128 gigs of RAM today? I mean, you couldn't use it. You'd have to, if you were running virtual machines or something like that. He also has a 32 core i9 Intel processor. So it's like the perfect machine for running virtual machines, I suppose. But in any case, generally speaking, as programmers, we don't really think about memory today. Every now and then we might run into a very scientific problem or something like that, where at that point we're probably advanced enough where we'll know why we care about memory for that particular problem. So reality is today, you'll never see somebody use a short. The go-to move today is if you need to hold a whole number, you store it in an int, even if you're only storing the number 3. Put it in an int. Who cares? If whatever you're trying to store won't fit in an int, you throw it in a long. Now, the thing is, though, you will see people using bytes today, but not for storage capacity reasons. One of the major applications of the internet today is video streaming, right? And things stream 1 byte at a time. So it's kind of that's the package size you're receiving it in. So you might, why take something, why take a can of soda and dump it into a cooler when you can take a can of soda and dump it into a can of soda, which is really difficult because you try to hit the holes. Good competition at night is to see how far away from the hole you can get. Still, it's a thing. That was what we did during our old leech hunts. Oh, no salt for leeches, trust me. Bad news, bears. Although those guys just dry right up, dead. So leave the salt rounds at home. All right. So, in any case, that's kind of the scoop with those guys there. So now, We talked last time, so 8-bit sign number. Oh, so we did the math for that last time. Why didn't you have the answer just... Didn't I threaten a quiz today?
Yeah,
Nah.
I was waiting for it.
Yeah.
I did threaten a quiz today, didn't I?
Yeah, you did.
So we're not
Yeah.
having a quiz today?
No, I always give quizzes right at the very beginning.
Okay.
And I would have given a quiz had I not gotten held up by a colleague with a conversation in the hallway because I walked in a minute or two late. So I'm like, oh, I don't want to burn more time. So we instead burned the time with leech stories. All right. So we looked at some conversion stuff last time. So like converting any base to decimal. It's the kind of the same pattern over and over and over again. So let's. So just as a quick practice thing here, if I want to convert 101110 from binary to decimal, so this would be an example of maybe what I would have given you on a quiz. All right, so go ahead and take 2 minutes. I'm not going to have you turn it in. Just take 2 minutes, solve this problem real quick. Binary is base 2. That's what binary means. Okay, you want to take a note of that. Yeah, binary is 2, yeah.
Yeah.
So let's take a look at this guy. So I'll go ahead and draw the picture out here. I need what, 6?
Oh, that's actually really sweet.
I'll give myself 6 little boxes. Yeah, I just learned how to use this program this morning.
I just put it in backwards.
All right, so that's 1, 0, 1, 1, 1, 0. I'm going to steal these guys, and we'll color code this. So this is the 2 to the 0's place. This is the 2 to the 1's place. This is the 2 to the 2's place. This is the 2 to the 3's place. 2 to the 4's place. 2 to the 5's place. All right, if we want to write that a different way, this way, go green maybe. This is the 1's place, the 2's place, the 4's place, the 8's place, the 16's place, the 32's place. So then the math for this is we take our value at that place, multiply it by the place. 0 times 1 plus 1 times 2 plus 1 times 4 plus 1 times 8 plus 0 times 16, which obviously we can leave the zeros out because 0 times anything is not going to turn in anything. Then 1 times 32. Take all that math, and that gives us a 46. So, binary number 101110 is the decimal value 46. So if that was the quiz, how many people would have gotten that right?
I put it in backwards.
So no. Backwards is close.
It was close enough. I mean,
No.
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 I mean, it might be for
Okay, so let's say you have a grenade and you throw your grenade backwards. And you just hurt your people. And that's what I do in all those first-person shooter games. I can't keep up. So I basically just, anything that moves, I fire at.
You can't harm your own team.
Better than my mom. She just punts it straight up.
Like you could hide. Oh yeah, you could hurt your own team.
Not on some games. Like,
Oh, so they've made him idiot-proof now.
there's
Yeah.
some where like you kill your teammate too many times, it just kicks you.
Oh yeah. Counter-Strike was kind of the old. Is that still a
You
thing?
kill your team and that you get kicked.
Yeah. So I
We
mean,
don't like that often.
right? Yeah. So I didn't know. Their uniforms, their outfits were so close. Right. So you just shoot anything that moves.
Above them if they're a teammate.
I can't read these names. I got old eyes. I shoot at anything that moves, and as soon as I'm out of ammo, one of my people has to come and kill me, so I come back fresh with a new gun. What's up?
I said at least you'd have no hesitation when you're in the corner.
That's right. Yeah, nothing. I don't. But usually I'm dead way before like anybody who's like even marginally qualified. All right, this makes sense how we did this one?
Yes.
Okay. So we can take that exact same pattern and let's say that we were converting 5, 3, 2 from octal. Here, we're going to test you. What's octal?
8.
Base 8. Good.
Goodness.
Got a golf clap there. All right, so 532 from octal to decimal. So 5, 3, 2. I'll cut out all these guys here. This is 8 to the zeros place. This is 8 to the ones place. This is 8 to the twos place. So this is the ones place, the eights place, the 64s place. So this is 2 times 1 plus 3 times 8 plus 5 times 64. And that's 346. So make sure you all can get that number, see that pattern. I'm rushing a little bit because we only have 2 minutes left. Leeches and sturgeons on Monday, and then we'll take some pictures and we'll text it to my brother during class. Now, this kind of crazy stuff maybe still does happen. We also, in high school, we had a kid that was arrested during school because he was storing human blood in his locker.
What?
Oh my gosh.
Hey, that, I can
Where was he getting blood from?
I had a understanding
No, I mean, I think this kid at least thought he was a vampire. I mean, he was he didn't go to lunch. He went to his locker.
Was it?
That's called murder.
Where are you going to get that from?
I have no clue. I just know that a kid that nobody went around. He was like the weird kid, and he was just unsettling. Was storing human blood in his locker, and wasn't going to the cafeteria at lunch.
But it's not illegal.
I
I don't know how
He
legal it
was
is,
technically
though.
wasn't
I
breaking
think
in.
there is some.
well, I guess it depends whose blood it was.
Yeah.
There's gotta be
If it's his blood, I mean, he's just weird. If it's someone else's blood.
You know, come to think of it, he was one of the kids that was buying a lot of those leeches.
I wonder why.
All right, questions, comments, concerns, bribes.
Sturgeon on Monday.
Sturgeon on Monday, leeches on Monday. All right, so homework is up. So it's the next 2 modules in the Mendix thing. Make sure you install the older version of the desktop modeler. I'm going to go down there right now and get it installed on the first 4 machines. So make sure you check out Slack, and I'll give you the 4 machine numbers that it's on. So if you need to come in and do your homework, you should be able to do that starting in an hour.